math fair project, I did Play-doh Math, and before we get started, I'm going to give y'all a little background information. Geometry is the study of how to use math to describe and investigate different points, lines, and shapes. There's a very basic three-dimensional shape that's called a rectangular prism, which is the shape of a box or a book, and it has 6 sides. If all the sides were the same, they would be called a cube, and so which they're not in a rectangular prism. Areas and volumes of cubes and rectangular prisms can be measured with the same geometrical formulas. Mathematical formulas describe geometrical shapes and are a way to calculate different properties of an object, such as area and volume. Volume is a unique property of the three-dimensional shapes because these shapes take up space in three different directions: length, the width, and height. In this activity, you will use Play-doh to make a model of a rectangular prism. Squish the rectangular prism down and see what effect, if any, does a changing of the dimensions of an object have on the object's volume. For the problem on this project, it's how does changing the shape of a rectangular prism of Play-doh affect its volume? And what do you notice happens to the length, width, and height as you squish the rectangular prism? For my hypothesis, I came up with if you use the same amount of Play-doh throughout the project, the volume will remain the same as you squish the Play-doh into a different shape. The height will decrease and the length and the width will increase. Alright, in order to test my hypothesis, we gotta follow a procedure. And what you're gonna do is you're gonna take 2 containers of Play-doh and you're gonna squish them together to form a rectangular prism. And it's gonna look kind of like this, and you're just gonna squish it the best you can. And once you get it in like the rectangular prism shape, you're going to take a marker and label L for the length, and you're going to draw a horizontal line since that's the direction you're going to be measuring. And then you're going to turn it and you're going to write a W for the width for the horizontal line. And then you're going to turn it one more time and label it with an H for the height, and you're going to draw a vertical line since that's the direction you're going to need to be measuring. Alright, once you have all 3 sides labeled, then you're going to take a ruler and you're going to measure each dimension. And then once you get that, you're going to go to your chart over here and you're going to record it in the correct column to find your length, width, and height. And then once you do that, you're going to take a flat surface and you're going to squish it down enough until you can tell that the shape has changed on the rectangular prism. And then once you do that, you're going to take your ruler and you're going to again measure the length, the width, and the height, and come over here and record it in your chart. You're going to continue that process for 5 trials. And once you get all 5 trials, then you're going to take your length, your width, and your height and multiply them together to get your volume. And you're going to do that for all 5. Alright, once you have that, then you're going to take another container of Play-doh, and you're going to squish it together, and it's going to be half the size, since on the first one you had 2 containers of Play-doh, and this you're only going to have 1. So we're going to see if the amount of Play-doh has effect on the volume. So you're going to follow the exact same procedure. You're going to label it with your W with the horizontal, L with the horizontal, and your height with the vertical to measure it. And you're going to come over here, you're going to measure it, and you're going to record it in your second table. Just like you did on the first, you're going to find it. And then you're going to squish it down again, and then you're going to re-measure it for 5 trials. Once you do all that, you're going to find your volume again by multiplying your length times your width times your height. Exact same process. Okay, and then once you have all that information down, you're going to take it and put it in a graph. And the best thing to do is put it in a bar graph so it'll be easier to see your data. When you're going to, on your x-axis, you're going to have your trials with your length, your width, your height, and then your volume. You're going to have all 5 trials, and then on your y-axis, you're going to put your measurements in inches. You're going to plug it in, and you're going to come over here and do the exact same thing for your second rectangular prism. Your x-axis, your trials, your y-axis, your measurements, and you're going to be able to compare the 2. And here you can see that as your height decreases, your length and your width increases. And then all your volumes remain pretty much the same, and it looks like they should be, but it's probably due to my measurement errors. Maybe I didn't get my edges square enough when I was measuring it, or I didn't read it right. Because over here it's about the exact same too. Alright, and once you have all that, we're going to go one step farther. Because we had 2 different cubes. prisms. And then one has 2 containers of Play-Doh and one has 1, so this one is half. And we're going to take the average volume of our original cube and our average volume of our second cube and compare them. In order to do that, we're going to go back to our table here. Alright, we have 5 volumes. Oops. You're going to take the sum of all 5 volumes, you're going to add them together, and then you're going to divide by the number of trials you had, so it'll be 5. And when you do that, you get 13.03. And you're going to do the exact same thing for your rectangular prism number 2. You're going to take all 5 of your trials and your volumes, you're going to add them together and divide by 5. And you're going to get 6.59. And when you look at the graph here, you can tell that the prism 2 is approximately half of your rectangular prism 1. That's what we predicted, since this was 2 containers and this is 1. So what we get from here is that, the amount of Play-Doh affects the volume in the prism. It's not whether we squish it or not, or change the shape, it's the amount of Play-Doh. And so, in my conclusion, I found that my hypothesis of if you use the same amount of Play-Doh, the volume will remain the same as you squish the Play-Doh into a different shape. As the height decreases, the length and width increases in a proportional manner so that the volume remains the same. By finding the information from my tables and graphing each bar as I did, I proved that the volume of an object remained the same even after reshaping the object. Finding the volume of the second rectangular prism, 1/2 amount of Play-Doh of the original rectangular prism, to be 1/2 the volume of the original rectangular prism, also proved that it is the amount of Play-Doh in the prisms that determines the volume, but not the